The Mutag biochip, developed and produced by Mutag in Germany, is a specially designed high-performance biofilm carrier with a high-grade pore system which provides a habitat for microorganisms. It is based on experience and extensive research and development. There are several hundreds of successful applications worldwide. There are MBBR plants which are treating more than 50 tons of COD per day, or more than 3 tons of ammonia per day. The Mutag biochip is used for water and wastewater treatment in general for COD or BOD removal, nitrification, denitrification, and also for NMOX application. The Mutag biochip is also used in many aquaculture applications for denitrification and nitrification too. The Mutag biochip can be used in MBBR-based plants or in combination with activated sludge as IFA system. The Mutag biochip provides a lot of advantages, whereas we will now especially focus on the subject diffusion. As known from biochemistry and cellular biology, the exchange of substances and oxygen is essential for cells as a precondition to uphold their metabolism. In order to keep them alive and active, the microorganisms need to be supplied with nutrients and oxygen, which is the sticking point that leads us to the topic diffusion and diffusion depth. As per the definition, diffusion shall mean the random but directional movement of certain molecules into a cell. The diffusion effect in biofilm processes has to be understood as the feed of substrate and oxygen molecules into the active biomass. Nutrients, like for example phosphorus as well as oxygen, diffuse from the surrounding water into the active biofilm and supply the microorganisms in the pores. In other words, diffusion is to be understood as the supply of biofilm or the microorganisms on the carrier with substrate and oxygen. Substrate refers to the pollutants being present in the water which are to be degraded by the microorganisms. A sufficient diffusion is an essential factor for the removal performance of active biomass. The diffusion depth is limited to approximate 0.5 millimeters, which can also be found in related technical literature. The term diffusion depth shall mean the limit of a biofilm layer thickness up to which the biofilm can still be sufficiently supplied with nutrients and oxygen. There are different phases of diffusion. The first one is the formation of a biofilm on the carrier surface. Then, the biofilm is getting thicker. However, if the biofilm layers are getting thicker than 0.5 millimeters, it comes to the development of inactive anoxic zones in the deeper layers, which will not contribute to the metabolism process anymore. As a consequence, these anoxic zones will only reduce the available active surface area and active biomass and in turn will lower the removal performance. A clogging or blocking of the Mutag biochip cannot occur, whereas clogging shall mean the unintended and uncontrolled growth of microorganisms, as it can be observed with many conventional tube-shaped carriers. At this point, it is of special importance to distinguish between active and inactive biomass. Active biomass is intended to be kept on the carrier and contributes to the removal performance. Inactive biomass is dead biomass, which can clog conventional carriers and only reduces the removal performance. As you can see here, both carrier types contain biomass. The tube-shaped carrier is completely stuffed with biomass, whereas the limited diffusion depth of 0.5 mm will take its toll. Only 0.5 mm of all the external space is occupied with active biomass. All deeper layers cannot be supplied with nutrients and oxygen, since the biofilm is simply too thick to be supplied. All biomass located in the deeper layers does not contribute to the metabolism's process, and is hence unnecessary ballast, which is still being moved around the MBBR, having a negative impact on the operational costs. As you will observe correctly, Also, the pore system of the Mutag biochip is completely filled with biomass, whereas the point here is that all this biomass is active and alive. In fact, the Mutag biochip provides a self-cleaning effect, which ensures that clogging is simply not possible to happen. Due to their specific shape and the light weight, the Mutag biochip carriers provide excellent motion characteristics, and once the carriers collide with each other or with the tank wall, any excess biomass which is trying to grow out of the pores will be sheared off, the so-called self-cleaning effect. Consequently, the biofilms are permanently kept at a thickness of 0.5 mm from both sides, whereas an optimal biofilm layer thickness and optimal diffusion is attained. On the other hand, there is no need to worry about a potential loss of active biomass on the Mutag biochip. The biofilm establishes inside of the pores, where it is protected against being flushed or sloughed off by the self-cleaning effect. In other words, the geometry of the Mutag biochip ensures that the maximum possible amount of active biomass can be permanently kept on the carrier. Dead biomass in the pores will be metabolized and displaced by active microorganisms, whereas the pores are permanently filled with active biomass. The active surface area of the Mutag biochip is certified with 4,850 square meters per cubic meter or 1,480 square feet per cubic feet. It is, however, not the surface area which is important for the removal performance. Crucial is the amount of active biomass in the pore system. A pure surface comparison of porous carriers is not correct and can lead to extreme differences in the removal performance. These pictures present breakage and abrasion. The abrasion is caused by the high kinetic energy which affects the carriers in the moving bed once they are colliding with the tank walls or once they chip off and abrade each other at high filling rates when colliding. On the contrary, there is no wear or abrasion on the Mutag biochip. Therefore, no maintenance, exchange or replacement is required due to the very low mass compared to its size. Simply brilliant. To summarize, we would like to name some further advantages. The Mutag biochip provides an active surface area of 4,850 square meters per cubic meter. Due to the optimized pore structure, the Mutag biochip can attach a manifold of active biomass than other foamed carriers can. The Mutag biochip is made from virgin PE, whereas its density and quality is controllable. Last but not least, we would like to highlight that Mutag does not only provide a plastic carrier media, but also competent process technological know-how. Mutag staff gained more than 20 years of experience in biological water treatment, and their process know-how was the basis for the development of the Mutag biochip. Together with the Mutag biochip carrier, Mutag also provides related supportive service and assistance based on their long-term experience with the special carrier media. Don't forget, Mutag is your partner and Mutag assists you with know-how. Thank you for your attention.